solving with common logs. All right, and here's what we have. We can still use the log property of equality. We can use the exponential property of equality. We can use the power rule for logs. We can use the product rule for logs. We can use the quotient rule for logs. We can use that wonderful log property, log base b of b to the y equals y, which is pretty cool. So all of the properties that we've learned so far, we can use. Again, what's different? We can use our calculator to take a log in base 10, and the log base won't actually be written in the problem, but everything else will be available. So let's just see. What if we had this? 3 to the x equals 15. All right. Well, how have we worked this in the past? Well, when we have an exponential, we have a few ways that we try to solve it. One way would be what? Well, could we rewrite to get them in the same base? Because if b to the x equals b to the y, then x equals y. And that's our exponential property of equality. So can we rewrite 15 using base 3? No, we can't. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is not 15. It's 27. So 3 times 5 is 15, but 3 to what power is 15? Not a whole number. So we don't know that one, right? 3 squared is 9. 3 cubed is 27. So somewhere between 2 and 3, right? But we don't know exactly where. So can we do that? No. Okay. That's been an option in the past, is that we could do that. Okay. So we can't do that. All right. So what else have we done in the past? Well, we have written, when we get stuck in an exponent, we rewrite it as a log. All right. So rewrite as log. Okay. So what would that look like? Well, we would say what? Log base 3 of 15 equals, and then there we are. Because I don't know what log base 3 of 15 is. Do you? No. Can we put this in our calculator? Not that we know of. Okay, no. So right now, the first way that we knew, because we can do this, but we can't rewrite 15 as base 3. Have we rewritten as a log before? Yes. Does that help us here? No, that doesn't help. No, doesn't help. So why was the no up here? It's not possible. We can't rewrite 15 using base 3. So not possible. So the two ways that we know how to solve this, now we're presented with a problem like, well, those don't help me. So now what? Okay. So here is the third thing. Here is the new way. You can solve this using logs. And this is what you can do. So here's the thought. When you cannot easily, come back. Well, for some reason, it doesn't want to write a Y. Oh, there it is. Oh my goodness, it's getting a little janky. Okay, when you cannot easily rewrite with powers of the same base. You can take the log of both sides. And so in the same ways, you can always put both sides, you can exponentiate both sides. Here we're going to take the log of both sides of our original equation, which is pretty nifty. So you might, I've had kids in the past that called it this. We're going to logify, which is just a silly made up word. But just like we can always add 2 to both sides of the equation, we can always multiply both sides of the equation by 7. We can divide both sides by 3, and again, because what did you learn a long time ago? You had a teacher somewhere that said what? You can do the same thing to both sides of the equation at the same time. That's a permission, and that is a property of equality. If it was equal here and I do the same thing to both sides at the same time, it's still equal. And so we're going to take our original equation right up here, because this didn't help. We don't know what base 3 of 15 is, all right? But we can take our original equation right up here and take the log of both sides. So it's going to look like this. I'll rewrite it. 3 to the x equals 15. And we're going to use the log property of equality, which just says I can take the log of both sides at the same time. And it'll be this. Log of 3 to the x equals log of 15. Whew, wasn't that swift? That's pretty neat. Okay, the log property of equality says I can do that. I can take the log of both sides right here. This is what I did. Now what? You should recognize a rule. What rule do you recognize over here that you can do? Because this is my variable. How can I need to get him out. I need to release him from being an exponent. So where can he go? Do you remember which rule? Yeah, you should, right? This is the power rule. So this x can come right out here. X times the log base 3 equals the log of 15. And what did we use? We used the power rule that says when you have an exponent, it can come right out here. Why? Because when you take a power to a power, you multiply the exponents. And remember, log values are exponents. One step to solving. What do I need to do to solve for x? That's right. Divide both sides by log of 3. So I'm going to move this because right now this is in the way. Okay. So we're going to divide both sides by log of 3. I'm going to divide this side by log of 3, and I'm going to divide this side by log of 3. All right, now, hold up. This is really important. Notice that this is the log of 15, close parentheses, divided by the log of 3, close parentheses. That is not the same as the log of 15 divided by 3 or the log of 5. It's not, okay? So that's really important that you catch that subtle difference. Log of 15, close, divided by log of 3. So this log of 3 divided by the denominator simplifies to x. So here we go. We're going to divide. Let me move this guy out of the way. And we have, I'm going to have to come over here, sorry. And now we have x equals the log of 15 divided by the log of 5. Now, division does not come before logs, which are essentially exponents. Exponents come first. So you've got to find the log of 15 divided by the log of 5. And good news, we can use our calculator. So just turn it on, and you're going to say log of 15, close parentheses, divided by, hit the log button again, 5, close parentheses. So it's going to look like that. Okay? You catch that? And now we're going to hit enter, and it's 1.6826. That's what you should get. So try it on yours, either Desmos or on your scientific calculator, or for all of you that requested, your TI calculator that I procured for you. So now we're going to come down here and say X is approximately 1.6826. And then the next one is 0.6194, so we'll round to 1. All right? That is how we do solving with common logs. I'll do another example in just a second.